All right, let's talk about algebra. You know, sometimes it can feel like you're trying to learn a totally foreign language, right? Well, what if I told you that's actually a perfect way to think about it? Algebra is a language. It's got its own words, its own grammar, and its own shortcuts. So today, we're going to learn how to speak it. You see something like this pop up, and it's easy to feel a little bit lost. It just looks like a jumble of letters and numbers. We're going to use this exact expression as our puzzle for today. And I promise, by the time we're done here, you won't just know what it means, you'll understand the structure, the grammar that holds the whole thing together. So here's our game plan. First, we'll learn the most basic word in algebra, which is called a term. Then we're going to put that word under a microscope to see what it's made of. After that, we'll check out a really clever shorthand using powers. And finally, we'll put all those pieces together. Sound good? Let's do it. Okay, first up, terms. You know, every language starts with simple words, and it's the exact same thing in algebra. Our most basic building block, our single word, is the term. Getting this down is absolutely the most important first step. So what in the world is a term? Well, the official definition sounds a little formal, doesn't it? Let's just break it down. Think of a term as just one single chunk of math. It could be a plain old number, which we call a numeral, or it could be a letter standing in for a number, a variable, or, and this is where it gets fun, it can be a mix of numbers and letters all multiplied or divided together. Let's look at some real-world examples to make this stick. The number 5, that's a term. The variable x, also a term. What about 4y? Well, that's just 4 times y, so yep, that's one term. Same goes for 8ab. And even something that looks like a fraction, like c divided by 2, that's also just a single term. Each one of these is a complete word in the language of algebra. And that brings us right back to our original puzzle. Look at it now, 4a plus 2b minus 5c. It's starting to make a lot more sense, right? This isn't just a random string of symbols anymore. It's a sentence made up of 3 distinct words. The first term is 4a, the second is 2b, and the third is 5c. The plus and minus signs, they're just the punctuation separating our words. See? We're already starting to crack the code. All right, on to our second part. Now that we know how to spot a word or a term, let's zoom in. Let's put one of them under a magnifying glass and look at its anatomy. What are the individual pieces that actually make up a term? This brings us to a really important vocabulary word, the coefficient. Now, the formal definition is a bit broad, but honestly, pretty much every time you hear someone say coefficient, what they really mean is the numerical coefficient. And that's way simpler. It's just the number part of the term. Now, here's a kind of cool thing about that official definition. It's really flexible. If we look at the term 4ab, we can say that 4 is the coefficient of ab. That's the normal way. But you could also say that 4a is the coefficient of b. It really just depends on your perspective. That said, 99% of the time, we're just talking about that number right out. So here's the bottom line. For a term like 7r's, the coefficient is 7. Simple enough. But what about a term that's just x? Where's the number? Well, it's got an invisible coefficient. Since x is really the same thing as 1x, the coefficient is 1. This is a super common thing that trips people up, so it's a great one to remember. Same for ab. Its coefficient is an invisible 1. Okay, moving on. Every language develops slang and shorthand to say things faster, right? Well, algebra does too, and one of its most powerful shortcuts is the idea of powers. A power is really just a fast way to write repeated multiplication. The number or variable you're multiplying is called the base. The tiny little number that tells you how many times to multiply it is the exponent. And here is the golden rule. You absolutely have to remember this. An exponent only applies to the thing it's directly touching on its left. And this slide shows that rule perfectly. On the left, we have 5d squared. That little exponent, the 2, is only touching the d. So this means 5 times d times d. But look at the right side. Those parentheses change everything. They act like a package deal, grouping the 5 and the d together. So now, the exponent applies to that entire package. It means the whole thing, 5d, times itself again, 5d. It's amazing how a tiny bit of punctuation can completely change the meaning. Okay, it is time for our final section. We've learned the key pieces of grammar. We know about terms, coefficients, exponents, and bases. Now let's put it all together and decode one complete algebraic term from start to finish. Let's break down this term, 4x to the 5th power, using everything we've just talked about. The numerical coefficient, that's the number out front, so it's 4.
The base is the variable that the exponent is attached to, so that's x, and the exponent, of course, is that little number up top, which is 5. See that? It's not a mystery anymore. You now have the vocabulary to describe every single piece of this.
And there you have it. We've taken something that might have looked like a confusing secret code and translated it into a language with structure and rules. You now know the basic grammar, the terms, coefficients, and powers that make it all work. You don't just have the tools to read algebra anymore, you have the tools to speak it. So the only question left is, what sentences are you going to build?